Hello students. In this video, I'm going to go over some basic calculus with parameters in Sage. Now this isn't a full-blown tutorial on how to do calculus in Sage. I'm going to do something very specific, and I'll take you down to the bottom to show you exactly what I want the final result to be. And that is, suppose that I wanted to compute cosine n pi x. I wanted to plot what that might be, or I want to be able to take integrals with the cosine of n pi x, or n is a parameter, and it's going to change from like 0, 1, 2, 3, and so on and so forth. This is just something very specific I want to do, and I just wanted to run a quick little tutorial on how to do some basic operations with a function like that in Sage. Okay, so let me scroll back up to the top. So first thing I'm going to do is I'm going to define some variables. I might have defined more variables than I need, but these are sometimes the typical ones that I'll compute, NKTY. Okay, so now Sage can be used to plot, differentiate, and integrate a couple different ways. You could use the plot, differentiate, and integrate functions in Sage, or if you define a function, as I do here, where I have f equals sine pi x, then that function will come with its own built-in methods. There are several, and those methods that we'll be exploiting today are plot, of course, differentiate, and integrate. So let me just hit Shift Enter. You can see the green and blue. Okay, so there we go. So once again, I can plot the command here of f of x, but I can also call the method f dot plot. Now let me just input a cell here. So if I do f dot, now if I hit the tab, you'll see, yeah, these are all the methods that are available to me in Sage for this function. Here's plot. So if I just hit plot like this, nothing showed up. Okay, here we go. Just waiting for that. All right, might have got myself. Okay, there we go. Now, sometimes you might have to hit these commands a couple of times, I find. But this is a vanilla plot, right? There's no label, axis labels, or titles. You can add those with the axis labels parameter for your function. You can also define over what interval you want to plot this function. I'm plotting over -1 to 1. If you wanted to change that, you can plot x, and for example, we can go from -2 to 2. Give this a second. There we go. And it's going from -2 to 2. All right, anyhow, here's the plot of the function with the fplot method. And here I've given my axis labels x with the LaTeX $, so I get that nice looking x there. And then I put blank for the y-axis because I wanted to leave room for this title. And I'm just trying to give you some additional parameters so you can see some of the additional features available to you in Sage. Likewise, you can differentiate, so we can use the diff of f with respect to x, and of course the derivative of sine pi x is pi cosine pi x. We could also use the differentiate method, and we could also integrate. We integrate the sine of x and we get minus cosine, but we had a pi x in there, so it's going to be with a u substitution, you'll see that you get a minus cosine pi x divided by pi. And then likewise we can do an f dot integrate. Now these functions can even contain these parameters, like I said, such as n. And here I'll define a new function, I'll call it g, and it'll be the cosine of n pi x. And then if I differentiate, notice that we will get the derivative of cosine is minus sine, but then we have the n pi x, and so the pi and n are treated as constants and they both pop out. And then likewise, if you integrate the cosine of n pi x, you get sine n pi x over pi n. So I just described what I did here. Now notice Sage, Sage, at least the way I'm doing it now, it lacks any arbitrary constant. Now the parameter n could be set just by treating g of x as a two-variable function. So the two variables are n and x, and so like g of minus 3 is minus 3 pi x. If I wanted to, I could do, let's see, minus 3, and then if I put in 1, of course, I should get, whoops, I forgot to define g. I'll do that up here. And then I'll hit that again. And I get a minus 1, of course, because that's the minus 3 pi. But if I just leave it without the second input, I get a 1. Now, it's n pi because the n appeared first and the x appeared second. Likewise, if I evaluated g of ky, then I would have k for where the n is and y for where the x is. So now that I have this parameter definition, let's see how a loop works. So the idea here is I'm going to generate all these plots and overlay them in Sage. So Sage is built on Python, and so for those of you that are familiar with Python, you'll recognize this for loop structure. So for n in the range, now range 0 to 4 are the integers 0, 1, 2, 3. So you could think of that as either 4, and that 4 comes from this right-hand side here, the right endpoint. It's going to produce 4 terms starting at 0. Or you could just think of it as we're going to produce a list of elements 0 to 3, and you actually don't get to 4, so it gets truncated. Okay, that's another way to look at it. And so if you wanted to just produce the integers from 1 to 4, you could do 1, 2, 3. I like to look at it as I'm producing 4 terms, and I'm indexing from 0. And then if I start from 1, that would be 4 terms, but I'm neglecting from the left. So I'm neglecting the 0, my index from 0. That's my perspective, but you can look at it however you want. The bottom line is you just should try to understand how the range function works. So from 1 to 4 is going to produce 1, 2, 3, and it truncates 1 less than 4. Okay, because we're indexed from 0 in Python. All right, now what we're going to do here is we're going to produce a list of colors, blue, red, green, and cyan, and I'm going to initialize my first plot. So this would be G0, where n is equal to 0, so that's cosine of 0, and that's going to be 1. So this is just going to be the line y equals 1. We're going to plot it from x is minus 1 to 1. I'm using the method form here, so g.plot. And the color is going to be C0. We're indexing from 0, so that's going to be blue. My legend label will be cosine. And notice how I can add strings together. So I concatenate strings using this plus sign here. And I turn 0 into a string, and I add it together. So I'm going to get this nice little legend label here, cosine 0 pi x. That's what this command here does. And then, now it's been initialized, I'm going to let n be in the range from 1 to 4. So it's going to be n is 1, 2, and 3. And then I'm going to add p plus the next plot. So this original p, where we have g of 0, is going to get added to g of 1, g of 2, g of 3. And then at the end, I'm going to show all of those plots, and I'm going to label my axes. And when you do that, you get this beautiful overlay of the plots, and you can see how cosine 0 gets you here, and it's y equals 1. Cosine of 1 pi x, yes, that's 1, period, and it starts and ends here, y is equal to minus 1, but you get 1 cycle. If it's cosine 2 pi, that's the green one. So you start up here, and you get 1 cycle, 2. And if it's cosine 3 pi x, you get 1, 2, and 3, just as expected. All right, Good luck.